Hi everyone. In this video, I am going to start the problems on the reflex klystron. So, reflex klystron oscillator, we have seen different formulas for repeller voltage and accelerating anode and output power, input power, and efficiency. Okay. In this first problem on this reflex klystron, we are going to see the calculation of repeller voltage and efficiency and the direct current which is generated in the application of the input voltage V0. So, the problem is given as the reflex klystron operated under the following conditions as V0 is given. V0 is nothing but the accelerating anode voltage, or we can say accelerating anode voltage, and L is given that is nothing but repeller space, that is L is equal to 1 millimeter that is given, and RSH is given as 15 kilo ohms. RSH is the reciprocal to the conductances of this reflex klystron GB, GC and GL, which is the reciprocal for the inversely proportional to the conductances. So RSH is given as 15 kilo ohms, and E by M, which is a standard ratio, E by M is equal to 1.759 into 10 power 11. It is 10 power 11, and FR resonant frequency is given 9 gigahertz. The tube is oscillating at resonant frequency FR at peak of n is equal to 2. That means the number of modes is given n is equal to 2, or we can write it as 1 3 by 4 mode. Assume that the transit time through the gap and beam loading can be neglected. Now what is the first value? We need to calculate the repeller voltage VR. In the second case, we need to calculate the current I0, and in the third case, we know we need to calculate the efficiency eta. Okay, so for this, first we need to take the formula. What is VR? Repeller voltage. What is the purpose of repeller voltage? Repeller voltage is the voltage required to apply the high DC amount voltage to the repeller electrode, which is used to repel the electrons which are coming towards it. Okay, so that the different types of electrons are generated and oscillations are being created. So now in the case of first one, the formula is the relation between the anode voltage and repeller voltage is VR0 by VR plus V0 whole square is equal to E by M, a standard value, it is 2 pi n minus pi by 2 divided by, this one is whole square here, 8 omega square L square. Okay, so now this is the formula. In this, what are the given known values? V0 is given, anode voltage is 600 volts, that is given. E by M ratio directly it is given, and 2 pi n is given, which is the number of modes, that is taken as 2 modes, pi by 2, and 8 omega square. Omega is nothing but 2 pi f. F is given 9 gigahertz. So from that we can write omega square, and L square. L is also given, which is 1 millimeter, that is also given. So let us substitute all these together. 600 by VR plus 600 square, that is equal to E by M. What do you mean by E by M? 759 into 10 power 11 2 pi into 2 minus pi by 2 divided by 8 into 2 pi into, what is 2 pi f? 9 gigahertz. 9 into 10 power 9 into 1 into 10 power minus 3. Okay, all these together, keep it in the bracket. That is 2 pi will also come, I think 2 pi will also come here. Okay, now it is square. Now after simplification of this one, we will be having the repeller voltage, which is 250 volts. Okay, I am not explaining the step-by-step procedure to calculate the value, because all these values are numericals. We can directly substitute in the calculator and get the value. Okay, after that some modifications are need to be done. because on the left hand side we are having 600 by VR plus 600 whole square. Okay, so after manipulating this we are getting VR is equal to 250 volts. Okay, now coming to the problem B. What do you mean by B? In the B case, find the direct current necessary to give a microwave gap voltage of 200 volts. That is nothing but I0 we need to calculate. So that I2, the current produced because of the application of V2, I2 is equal to 2 I0 beta I J1 of X dash. J1 of X dash. So 2 into I0. I0 is nothing but, what is I0? I0 is the induced current because of the application of the anode voltage. Okay, that is generated in the right hand side direction in the circuit, which is a positive value. So I0 and beta is nothing but coupling coefficient. So beta I J1 of X dash. J1 of X dash we know very well, which is a Bessel function. Assume beta I is equal to 1. Assume beta I is equal to 1. Then what happens? I2 is equal to 2 I0 J1 of X dash. Okay, so now take the value for V2. Voltage V2 is equal to I2 into R2, or we can write it as R2. Output side we have a shunt resistance RSH. Okay, so that I2 is nothing but, already we have I2 here. So 2 I0 J1 of X dash into RSH. Okay, so therefore I0 is equal to V2 by 2 J1 of X dash into RSH. Okay, substitute the values which are known to us. So that is equal to, voltage is given in the second statement itself, 200 divided by 2 into 0.582, already has calculated and given the direct value of this Bessel function. Okay, so 15 kilo ohms, which is nothing but 15 into 10 power 3. So after simplification of this one, we are having 11.4547 milliamperes. Okay, so milliamperes and 10 power minus 3, actually it will come because in the denominator we are having 10 power 3, that will be coming in the numerator as 10 power minus 3. So that's why you can write it as in milliamperes. Okay, now coming to the third case, which is an efficiency of this reflex klystron oscillator. Efficiency eta is equal to 2 X dash J1 of X dash divided by 2 pi n minus pi by 2. 2 pi n minus pi by 2. So that is equal to 2 into, what is X dash from the table? It is 1.84 into J1 of X dash. What is J1 of X dash? Which is the highest value we are taking. Among the values that are present in the denominator, we should always go for the highest value because we don't have any value for the X dash. Okay, if we don't have any value, definitely we can substitute, or else we can take the which is the maximum value. Okay, so in the denominator also 2 pi into 2 minus pi by 2. Okay, so after simplifying this equation, we will be having eta is equal to finally 19.48%. Eta is equal to 19.48%, which is nothing but efficiency of this reflex klystron oscillator. Efficiency of reflex klystron oscillator, which is calculated and obtained as the 19.48%. Okay, so this is the way how to calculate the current, output current and repeller voltage, and as well as efficiency, electronic efficiency under all these conditions. So in the next class I will explain about the calculation of output power. Okay, output power again when the input power is being reduced because of the beam, and we can also calculate the efficiency of the reflex klystron with the different problems. Okay, thank you.